alone and miserable. I am taking Sydney back. She is my daughter. No!
Welcome back to the bonding game, making excellent compounds since 1869. Our next question is for Bachelorette number 2. Tell us about where you live.
Well, I live on the 3rd floor of my building in room 17. It's a very nice place. I live right below my friend Fluorine and above my friend Bromine. We're all in the Kappa non-metal sorority.
This next question is for all 3 of our eligible bachelorettes. Tell us a few things about yourself.
Well, as a metal, I'm very ductile and very good with electricity.
Well, as a non-metal, I'm not very bright, but I'm very sensitive and soft.
Well, as a metalloid, I'm very dull.
Bachelorette number 1, tell me a bit more about yourself.
Well, some of my physical properties are that I have silvery white hair and I weigh 24.3 atomic mass units.
You have 24 protons and neutrons in you. At least I am very beautiful on the outside and inside. Physically, I am very svelte and fragile, but chemically, I can get very heated if you bring me near my oxygen.
Bachelor, it's almost time for you to make your decision. You may have one final question.
Bachelorettes, how many valence electrons do you each have?
I have 2 electrons in my outermost shell.
Only 2? I have 7.
I have 3.
Well, if I bond with Bachelorette number 1, I would have to clone myself because I have 1 valence electron and she has 2, so that's not realistic. And I can't bond with Bachelorette number 3 because she's a metalloid, so I'd have to go with the non-metal Bachelorette with 7 valence electrons.
Bachelorette number 2!
Sodium meet chlorine. Oh, and what a salty couple these 2 make.
Hey there everyone, welcome back to Chem Cooking with Carol. You guessed it, I'm Carol. That right there is my crazy chemistry cat. This is Dr. BrINClHOF. I call him that because BrINClHOF stands for all of the diatomic elements. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Today, we are going to make 2 different mixtures, salad and sugary sweet water. Alright, now I'm going to take this salad here, and I'm going to mix it with these cute little tiny tomatoes. And when I pour all the tomatoes into the salad like that, kind of mix them all around here like this. So see that, notice how the tomatoes and the salad aren't actually combining together to make a new mixture? That means it's heterogeneous. Now the sugar, on the other hand, we just pour a little bit of sugar in, we can actually see that the sugar is combining to form one singular substance. You actually can't even actually a little bit there. You can't even actually see the sugar anymore. It kind of all just disappears. That means it's homogeneous. Now let's talk about physical and chemical changes. First, I'll eat a little bit of the salad, drastically reducing its volume. Now we can clearly see that after that physical change, the salad is still salad, just its physical state has changed. Physical change. Now, if we were to burn this little sucker right here, make some caramel, like so. Oh, it's not on. Now, if we were to burn this little sucker right here like that, we can see that the sugar is actually heating up here. The fire actually activates a chemical reaction between the sugar and the oxygen. Oxygen in the air reacts with the sugar, and these chemical bonds here in this delicious caramel are broken, making it a beautiful little chemical change. Isn't that sweet? Time to bring off. No. I'd like to buy a 3.
There are 2 3s.
Let's see, there are 6 O's on the right side, so I'd have to put a 2 up in front there. Then there would be 4 FE's, making that FE a 4. I'd like to solve the puzzle, Pat. 2 Fe2O3 plus 3 C yields 4 Fe plus 3 CO2.
That's correct. Next puzzle, name the ionic compound.
Let's see. The cation, magnesium, will just stay the same. And the anion, nitrogen, I'll have to add the suffix I to it. So the answer will be magnesium nitride.
That's correct. Next puzzle, name the covalent compound.
Well, there are 2 hydrogens, so I'll add the prefix di, and there's only 1 oxygen. So I'll add the prefix mono, but because oxide already begins with an O, I'll have to just combine the 2 O's, and it will be dihydrogen monoxide.
That's correct.
I'll take scientist for 200.
He discovered the nucleus.
Who is Rutherford?
That is correct.
Scientist for 300.
He was the first philosopher to come up with the idea of the atom.
Who is Aristotle?
Incorrect.
Who is Democritus?
Yes.
I'll take experiments for 300.
This experiment led to the discovery of the electron.
What is the cathode ray tube experiment?
Right you are.
Experiments for 400.
This experiment led to the discovery of the nucleus.
What is the gold foil experiment?
Yes, Rutherford's gold foil
Tú piensas que me puedes dominar, pero no se puedes porque soy más arriba en la escala de actividad.
Welcome back to CNN News, the Chemistry News Network.
Tonight, we have a special report of a fire breaking out in a chemistry lab.
Although all the chemists in the lab remain unharmed, unfortunately, we saw some painful chemical reaction take place, Mark.
Like what, Susan?
Well, there was a nasty smell. It almost smelled like rotten eggs.
Some of the chemists report that there was some discoloration in the chemicals after the fire.
Oh, yes, and Mark, if you look very closely, you can see that there are some traces of bubbles being produced during this reaction.
Oh wow, Susan, would you look at that? There's a crusty powder all over the floor.
1 second there, Mark. I am now getting confirmation that, what? The fire was actually very, very hot.
You don't say!
Is he gone?
No, he's not gone.
How do you know?
Because matter cannot be created or destroyed. So, he will never truly be gone.
Okay, well, is he dead?
Oh, yeah, he's dead. But he'll never be gone because of science.
But does that really matter?
Well, is this dead body energy? Is he a force? Is he a vacuum? Is he time? Is he a reflection? Does he occupy space and have mass? Well then, yes, he is matter.
I'll just watch a DVD.
This is a BBC documentary on juvenile heroin use in Afghanistan.